Alright, today we're gonna work on example for static routes. Actually just one. So um, I'm working with Packet Tracer. I know some people have GNS3 set up, or you have your NetSim, Boson lab environment. This is will work with any of those platforms, but if you don't have Cisco Networking Academy ID, it's netacad.com. Like now you can see it, netacad.com. Uh, make an ID, and then you go to, on this tab, Resources, go down to Download Packet Tracer. You get the most recent version of Packet Tracer. So I haven't configured anything here. I just wrote out some IP addresses and interfaces just to um, I don't know, quicken it up. So let's get right into it. I didn't really write out an agenda, but I guess along the way I'll just explain stuff. This is for the extreme beginner, I guess. I'm just doing this more as a way to review materials and practice my way of doing an off-the-cuff explanation. So without further ado, if I was going to start here, um, I guess this is for anybody who's never used Packet Tracer. Your connections are down here, any type of cabling. You can use auto connect, but that's gonna, when you use this, it's going to, it's not going to give you an option where you can plug something in. So, like for example, if you do the auto connect, it just boom, boom. It, I don't know what interface it's just plugged into. I don't know what cable. Well, I can tell from what color the cable it is, but. And another thing, when you want to delete something, you can just press this, and then it's really um, kind of confusing at first. Then you gotta go back to like the select all mode. So um, let's look at our interface. I've already inserted the serial module, which you'll need to create this WAN link between two routers. So let's just say over here is Atlanta. We have our router in Atlanta. And on this side, we have a router in, let's say, Pittsburgh, Pennsylvania. And in each of these um, routers, I'm going to use, for example, based on some stuff that you'll probably see in the ICND1, which is serial modules and dealing with their controllers. Um, if you just drag and drop this router, um, the 2901 or the 2911. We'll do the 2911. It's not going to have the serial module installed, and so what you're going to need to do is power off by hitting that button. And then this HWIC 2T is a 2-port serial high-speed WAN interface, so we're going to drop it into module 1. You zoom in, you can kind of see, I think, no, it's module 0, excuse me. And then if you so desire, you can put covers here, which is kind of nerdy. And then we're going to want to turn it back on. If you try to go the command line or config, it's going to warn you, hold on buddy, it's still decompressing the file image. So we're not going to do anything with this router, so I'm going to delete it. So like I said, I already have a serial interface installed and my router is booted up, so let's see what I have here. I have one too. Alright, so we've gone past that. So the next thing that I'll mention is the type of cabling. So whenever you create a WAN network, there's a concept known as setting the clock rate, and you set the clock rate on the end of the cable, which is the DCE, And how I remember that is there's a C in it, which doesn't stand for clock. It's just kind of um, convenient to kind of memorize it that way, I guess. Um, so we're going to go ahead and this is saying, yeah, serial DCE. If you see it down here, it shows you, and it has that little clock thing. So I'm going to go ahead and set the serial DCE end of the cable to serial 0, 0, 0, 0, and then this end is going to ultimately be the DTE. I forget what they stands for, but that's not where you set the clock rate. So, but Packet Tracer is going to do it automatically for me, setting the clock rate, and I'll show that example. So this appears to be up, but let's just check out what I just explained. So in the exam, there might be questions, and I've come across this while studying, um, where it asks you, which of these routers, on which of these routers do you have to set the clock rate? And to figure that out, here, let's go to the one that I know that doesn't have the DCE end of the cable. So this says the DTE end, and we are going to um, so we're going to go into enable mode and issue the command show controllers. And this is kind of weird. You got to press enter. Serial 00. There it is. DTE. Transfer and rate clock TX. Transfer RX. Uh, receive clocks detected. So right here, this is the DTE side. So you wouldn't issue the command clock rate to adjust the clock rate. So let's go back to router 1, and I'm going to issue the command enable show controllers. I'm going to hit enter, 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 DCE. There we go. And here's the clock rate. So that's cool. I'm going to manipulate that clock rate just because it's a, I don't know, use case you might have to perform during the exam. So of course we're going to go into configuration terminal, and since this is on serial 000, we're going to go into interface, which you can put INT. There's many different ways to write this out. I'm sure some of you might be cringing and when you see me write this out the whole way. But anyways, interface serial 00. So now we are in the interface configuration terminal, and I can do a question mark, and then you see clock is already here. So clock. What else can I do? Question mark rate. All right. Clock rate. Question mark. Oh, these are all the values. And a popular one seems to be this guy here. So at least on the testing materials I've seen. So there we go. We've issued a different clock rate. We're going to back out, show controllers. And here's our new clock rate on the DC end of the cable on serial 000. All right, let's give these interfaces their IP addresses. So we can see, I'm going to scroll down a bit. So we're in the interface, we're just going to go IP address 10 dot, and then insert our subnet mask, which is /24. Okay. No shut for good measure. And that's it. We don't need to apply anything else to that interface. Let's go ahead and do the same over here. Oops. So we're in the serial interface 000 IP address. No shut. Okay. So now we have our IPs allocated to each of those interfaces. So let's go back to router 1 and configure the first. Actually, let's look at what. Let's pretend we're in a testing environment. We need to figure out what interfaces are there to apply this IP address to, so we can plug it into the computer. So, and backs you out of it, or control Z or whatnot. So we're gonna go show IP interface brief, or BRI. So I could have written that out. Show IP interface brief. Same thing. So it looks as though this is some old config that I have on Gig Ethernet 00. And here's our recently configured serial IP interface. So we're going to assign a different IP address to Gig 00, the one that I have listed up here, and then we'll cable it up. So there we go. Alright, it matches up. So since I configured that port, I'm going to make sure I select that port, Gig Eth 00, the fast internet. And let's double check my settings here. I have it statically set up. I didn't set up a DHCP server, obviously. So 200.200, and I configured the default gateway accordingly, statically. So there we go. Let's do the same thing over here. So we got our, let's see, we already configured the serial interface. So let's jump on over to gig 00 like the other guy. Now we're in there. IP address 192.168.100.1. That's what I have written here for this interface. And then subnet mask /24. And I'm going to make sure it's not shut down. Double check our work. Matches up, matches up, matches up, matches up. Okay. Cable. So, oops. From gig 00 to fast ethernet 00. Let's double check our config. Default gateway matches up. IP address matches up. Statically configured. Same subnet. Alright, so if I were to try to ping between this host to this host, it's not going to work because there has been no router static configuration nor dynamic configuration applied to either of the interfaces. So to demonstrate that, um, we'll just try to do it anyways. 92168.100.100. So currently I'm this computer. I typed in the IP address of the foreign computer on another broadcast domain, and we get a reply from 200.1, this um, our default gateway, saying, I don't know how to go there. I really don't know. Can't help you out. The destination is unreachable. So right now we have three broadcast domains: the 192.168.200, the 1110 network, and the 192.168.100 network. And in order to be able to communicate between these two networks, we are going to have to at least set a static route, which is probably the easiest, but it's unmanageable in large environments. But for this use case and for the ICND1 objectives, then why not? Let's just try it. So I like to think about it as I'm I'm this host, and I want to talk to this foreign host. And the way to program the router with the static route is it's kind of like saying, I'm going to tell you about this foreign network. Use this interface to get there, right? I'm going to tell you about this foreign network, and this is the way to go. This port is what you should use in this network to get there. And that probably sounds really, I don't know, off the wall, but when you come to write the IP route um, configuration, then it might make it a little bit more sense, because sometimes I even mix it up, but this is going to help me even more solidify it. So we're going to first of all show our IP route table. So show IP route, and you'll see connect C is connected. So physically there's the 10.1.1 network and the 192.168.200 network. They're both in our routing table because they're both physically connected, right? We are going to set up a static route, which the prefix is an S. So if this is done correctly, it will show up there, and we will be able to send traffic from our endpoint here to the um, foreign endpoint. But if we don't configure a way back, that ICMP packet is going to make it there and try to come back, but it will be dropped to this router because it has no route to get back. So we'll do that, and then we'll configure both, and we'll watch it on the way through. And this video is taking way longer than I thought it would, but oh well, cheers. So we got to get into the configuration terminal to issue the static route, so IP route. And like I said, this is the network I'm going to tell you about, and this is how we get there. So IP route 192.168.100.0.255.255. This is important. This .0 because you're giving it a network address, which is, you know, proven with the subnet mask. So don't try to put in, you know, 100. I think you can do that with the IP route host. Just don't quote me on it. So anyways, IP route, this is the network that we'd like to communicate with, right? That's why it's here. And then the next one is, this is how you get there. So 10.1.1.2, right? This is the way you go. So IP route, foreign network, followed by next hop address. So I should just write next hop. If I had a fancy camera thing, I'd write next hop. You know, end with Alright, so I'm gonna back out of here, show IP route, and right here the S, static. It's saying I know how to get to 192.168.100 network. Then I'm gonna administrative distance of 1 because it's directly connected. Or sorry, because it's a static route. And I go through this IP to get there, right? So let's test our theory on being able to uh, reach this host, but not be able to receive one back because we haven't um, configured this other host. So we are going to make him send it over here. We're going into simulation mode. Whoa. Whoops. Let's just get out of here. And if you're unfamiliar with Packet Tracer, there's two different modes where I just clicked down here and went over to simulation mode to see where this packet that I dropped and then the destination of the packet, see how it traverses the network, and you go forward with this button. So I'm going to click it. It sent the ICMP, the ping packet to the router. Oh, the router knows. I can go, I can get to this network through this device. So it just sent it right over to that IP port and it reaches the host. Hey, this endpoint knows is uh, to send it back to the router. It doesn't know how to get there, so it's gonna try to send it back to the router. And one more. Oh, it made it back. Did I already have config in there? Hold on. Show IP route. Oh, I had already configured the way back, so it knows how to get to the 200 network from this IP address, 10111, right? So, sorry, I guess I had already configured that. It would have been discarded here. So let's actually remove the static route and see how it would have failed. Because if we're explaining static routes and how to enter them and enter them correctly, then we should also explain how to remove a static route. And so, especially if we made a mistake, like tonight. So, like most things on Cisco routers, you can negate or remove uh, any configuration by simply starting it with no. So we're going to go into the configuration terminal so we can make changes and simply preface it with no IP route. And it was for the, you can see right here, the 200 network. So 192.168.200.0 via the next hop of 10.1.1.1. Enter. Back out. Show IP route. And it used to end with the static route here. Now there is no static route. So we're going to go back and do that same ICMP test, and this time it should be dropped by this router because there is no static route in the IP route table uh, to get back to return the ICMP echo request. So we'll go back into simulation mode. Here you can see what happens in the event. So um, I bet this guy is still returning, so we can just go forward, and you see right here, it's going to drop the reply, right? And it sends it back as destination unreachable. That's why that went back. So you saw another one made it, and coming back to tell them okay, and it's dropped. This is CDP traffic, Cisco Discovery Protocol. Um, just ignore that. It's just more demonstrations. Maybe I'll do a section on that. So anyways, we'll do it one more time. We're going to send an ICMP packet from this host to this host. It will reach it because we do have a static route configured here. Upon return to its sender, it will be discarded at this router. So going forward, here comes ICMP packet. Static route is there, so it is shot over to the static route. Um, Reaches the intended host, goes back to be delivered to the original sender, dropped by the router because there is no route back, and sent back to uh, the source, and it failed. So back to real time, we'll add it once again to finish up. So configuration terminal IP route. Um, this is the network where I want to go. 92.168.200.0, and this is the next hop. This is interface. This is how I get there. 10.10101. Enter. All right, now let's try this again. We'll send it from this host first, see if it even just makes it from the first go. So go forward. All right, this is the pink ICMP packet. You can see their color codes over here. It makes it to the router and it is forwarded. So there's ICMP traffic actually coming back and forth right now. So everything is reaching everybody. Everybody's having a great time sending packets back and forth on this Monday night. Um, and then some more Cisco Discovery Protocol sent from the routers to, from the router to router to endpoint to see who's their neighbors, how they're doing, if they